a couple curveballs in there, but that's good because there's a couple curveballs in almost any database assignment that you come up with that's of any size that's realistic. Let's refresh our memory of the tasks that we had from last time, and then let's go about developing the solution. The way I'm going to do it is I'm going to walk through the process that I would go through to do this, and then, at any point, feel free to ask me questions or so on. All right, let's pull up. If you notice, last time I actually took a photograph of the screen. Something I would have never thought to do, but I saw a student do it once, and it was like, hey, it's perfect. All right, college bookstore inventory. They have books. Books can be of one of three types. There are classes, of course. There are multiple sections of each class, or there's a potential for multiple sections of each class. Each section is associated with a professor. Each professor that teaches a class, that teaches any section of the class, can determine the textbook that they're going to teach. And there can be multiple books per section. So I could want, like for example, in my 216 class, there's 2 textbooks. All of the professor's sections, though, have the same books. All right. To start out with, the first thing I'm going to do is I'm going to identify some entities. Okay? And then we'll start looking at the relationship. There's a number of ways that this can be done. There's essentially the bottom-up or top-down approach. In the bottom-up, you'd gather all the pieces of information that you need in your system. The professor's name, the section, date, and time, and so on. And then sort of bring that up to a structure and figure out how to structure those individual elements. My own preference is to do top-down, where we look at the main entities first and then sort of drill down into the entities or the attributes of those particular entities and the relationship. That way we sort of get a look at the big picture first, which I think is always important to keep in mind before you start getting buried into any details. All right. First thing we're going to do is I'm going to jot some entities down. And I'm not going to do any relationships yet, but I'll jot some entities down. And then we'll pause, I'll talk about them, and then we'll start talking about relationships. All right. First entity are books. Second entity is the type of book, whether it be a new book, a used book, or an e-book. There are classes then. All right. There are sections for those classes. There are professors. And there are a professor's book choices for the class. Now, I'm just roughly drawing the entities here, and I probably will redraw this to give myself more space and to rearrange a few things as I'm thinking about that. So let me go and redraw that to give a little bit more space. Books we're going to have up here. Type of books we're going to have here. We are going to have classes down here, sections over here, professors over here, and the entity, the professor's book choices for class. Now that's sort of an awkwardly named entity. And that's almost a tip-off that we may need to think about this a little bit more in terms of developing keys and et cetera, and truly what's going to be stored in that entity. Now, if you go back to the original problem definition, essentially what I did is, for the most part, I took and I extracted nouns out of this. Now I used, it isn't literally taking all the nouns out, but for the most part I did. Books, yeah, we got a book entity. New, used, and ebook, I guess you could ask, why don't those become entities? Well, those are really the same entity. That's a type of book. All right? You might ask, why not simply have those as attributes, maybe? And, well, by not making them attributes, by making their own entity, we can easily then add another format for a book. Maybe a, 3D hologrammatic book, when that technology evolves. All right? And we're not restricted or limited to just those. And we also have the benefit of we can apply referential integrity constraints to these, if we have those in a table. All right, classes, that's pretty obvious. Sections, professors. The professor's choice of books is implied there. That's that one table. And that's sort of the rest. So I have those entities. Now, these entities might seem simple enough, but there's some things I want to talk about the book entity. What does a book entity mean to you? It sounds like a dumb question. It sounds like I'm asking you what a book is. In this context, what does that book table or book entity represent for you?
All the books in the library.
Well, this is a bookstore, not the library. But so what you're saying is this represents every individual. There is one row in that table for every book that's in the bookstore. Okay. All right. That's one possible definition of book. All right. I'm not saying right, wrong, or indifferent. Is there another way to interpret that? To interpret book? Yeah, but we kind of have that covered with this one. I guess what I'm saying is there another way to interpret that? Well, let me ask you this. How many books are there for this class? There's one, right? There's one title that you have to buy. But there should be as many books as there are students. So, depending on your perspective, a book could mean an actual physical book, or a book could mean a title. All right, the, edition 1 of Head First Java, that's a book. Or each copy of Head First Java could itself be a book. Now, the question is which entity do we need? All right? Well, the answer is we probably need both of them, right? Because a professor doesn't assign individual books in the bookstore. Like, I'm not going to say, for this class, you will use that book that's over there in that corner, and you can't use the book that's next to it on the shelf, right? In fact, if I select a book, you might order it from Amazon or buy it from a friend that has taken this class before or whatever, all right? So the point is what a teacher selects for a class isn't an individual book. There's nothing special about that book. The teacher picks a title. Yet, if you look back on our definition of the problem, we are keeping track of inventory. So we better know about each individual book, right? So we actually need both entities is sort of the bottom line. So for convenience sake, I'm going to keep the definition that we use for book to say that a book is an actual copy of a particular title, and I'm going to use title to represent, the name and edition and author of the book. So there'll be a one-to-many relationship between title and book, which is what a bookstore would need, right? If they're going to look at upcoming, if they're going to look if they need to order some things for summer class, they'll look at what textbook title I asked for, and they'll look to see how many copies they already have on stock, right? Because if they already have 20 copies of the HTML book on stock, they don't probably need to go and order anymore. But if they only had one copy of the book, they probably would. So I'm going to go and I'm going to change this to add book and title to this. Whereas again, title is the card catalog entry, if you will, for the book, and the book is the individual copy. All right, so let's start building relationships. And all the relationships except one, in my mind, are pretty straightforward, excepting for the fact that one is a pretty major one. All right, so we'll take some time discussing the options as far as that goes. We already said between title and book there's a one-to-many, right? For a given title, there may be many copies of the book. But a given book is only one title. All right? Relationship between book and type would be like this. All right? Because again, a given copy of the book is either going to be a subscription for or a license for an e-book, or a copy of a new book, or a copy of a used book. So a given book is only going to be of one type. But in the bookstore, there's a bunch of new books, and there's a bunch of used books, and presumably there's a bunch of licenses for e-books. So that's what those relationships look like. All right, so far, that's pretty straightforward. Now, let's look at the relationship between professor and classes and sections. A class might have multiple sections. All right? So, my 216 class, there's a day section, and there is a web section. But my day section is only CISS216. I don't have, I'm not also teaching, Latin at the same time. All right? So each section really only relates to one class. And each section is taught by a professor. But one professor can teach multiple sections. Here is where sort of the problems start. I'm going to end up redrawing this relationship. Because let's consider something like this. I could say that a professor can choose multiple for a class. And I could say something like this. And then each one of these is related to one book. Here's a problem with this approach. The problem with this approach is there's nothing that constrains this table to be limited to only the professors that are teaching a particular section. Right? In other words, I could put in this table that I pick a book for a German class, or I picked a book for a phys ed class, or I picked a book for an art class. Because there's no relationship between the section who actually is teaching this class and the professors that are selecting the books. And that to me sounds like a problem. All right? Let's look at what this key would look like if we were going to implement that table. Remember I said this, we knew this guy was going to be a troublemaker. All right? Just by the name of it. If we made this key, if we made this table, the key would probably be professor ID, class ID, and book ID. What's wrong with that? What's wrong with that is this actually violates the fourth rule of normalization. We talk in the 143 class about 3 normalization rules. There's actually a couple more. In other words, there's a dependency between book ID and the professor and class. You tell me the professor and class, and I can tell you the book ID that they use. All right? So that isn't exactly right. So here's what I'm proposing as a better solution for this. And if you're not clear why this is inadequate, hear me out, and then we can go back and revisit it. All right? I should call this title, not book, to be consistent in the terminology. And then type. So one-to-many, one-to-many. All right. This, in my mind, is a better structure. All right. Essentially, what I've done is I've introduced another entity that says, what are the valid professor-class combinations? All right. If you think of it, there are hundreds of classes on campus. Every professor only teaches a handful of them. I probably teach as many classes as anyone does, as many different classes as anyone does. And I only teach maybe a dozen or so, not necessarily all at the same time, but throughout different semesters. All right? So therefore, what we're going to do is we're going to have a table that's going to say what professors can teach this class or are teaching this class, however we want to put it. And that is an intersecting table between professor and class. When we do that, then we can make sure that only the right people, the people who are authorized to teach that class, are assigned a section. With this structure, any professor could be assigned to any section. And we know that's not really the case, right? I'm not going to teach any art classes, or I'm not going to teach any engineering classes. I'm not going to teach anything but CISS and actually now a marketing class. All right? So this puts that constraint on to say a person can't be assigned to a section unless they exist in that table. All right? Remember, when you have a choice, it's always better to implement a constraint in the database instead of having your application do it. So this will implement the restriction that says, hey, this person can only teach these courses. I then can have, for each person that is authorized to teach this class, I can have the title of the books that they are using. And then that table is linked to the title table. All right? So, in essence, this will have, if we're talking about keys, this will have a professor ID, this will have a class ID, this will have a section ID. This, again, you typically have two choices when you create a intersecting table like this. I could use a generated key, which would be in Access an auto number key, sometimes called a surrogate key, or I can actually use a natural key that is combined, or a composite key rather, and combine the other two. For simplicity, in this case, I'm going to go and I'm going to make this, the key of this table, the professor ID and the class ID. All right? This will have the title ID. This will have the book ID. This will have the type ID. This will have professor and class ID and title ID. Now I know I said in that other context that that was a problem. That was a problem because, and again, it might not have been the exact issue that I stated before now that I think about it, but it was a problem because there was nothing that would constrain this table to only contain professors and classes that were a valid combination. But by putting this entity in here, I make sure the only people that can pick books for a class are the people that are authorized to teach that class. Then, as far as foreign keys go, this would have a foreign key both for professor ID and class ID. This would have a foreign key for all three of these. And this would have a foreign key of type ID and title ID. I didn't anticipate this little messiness in the middle here. All right? But as I thought through it, as one of the students showed me his example, and again, I thought, well, let me do it here on the spot. As I was thinking through it, I realized that you actually need that entity to make sure that you can constrain who can pick a book for a class and who can teach a class. Without that, we have the potential of having someone picking a book for a class that isn't necessarily signed on to teach that class. All right, and that wouldn't make sense, and if we can control that on the database level, we would. Any questions about this? It was a little confusing, perhaps. I do apologize. It had some issues that I didn't necessarily think were in it originally. But the good news is, all right, the good news with this is, or the lesson rather that we can learn from this is really database design is not necessarily a cut and dried thing. It's not just a matter of only applying mechanical rules. There are some mechanical rules, like I talked about last time, as far as how you implement a one-to-many relationship and so on. But you still have to take what you know about the organization and integrate that in. So one of the things that I integrated into the design that wasn't necessarily mentioned here, but is based on my own knowledge of the organization and how it works, is that not everyone you can only pick books for the classes that you teach, and not everyone can teach every class. So that was sort of an implied restriction just based on what we know. One thing to keep in mind when you're doing database design, I've heard this old saying, and I think it is it sums up the dilemma of software development as well as any paragraph that I've ever heard. All right, goes something like this: the old saying, the biggest cause of problems in software development projects results from not listening to the customer. All right. The other big problem with software development results from when you listen to the customer. All right. What does that mean? Obviously, you need to listen to the customer. They're the subject matter experts. You know, it's their job to understand these things and to know, not to understand databases, but to know how the organization works and that sort of thing. However, you have to apply your own judgment and your own experience and your own knowledge of databases to that problem too. You don't necessarily blindly accept what they're telling you. And this goes for if you're developing web pages, if you're developing databases, or if you're developing other applications. People have made the point of Steve Jobs, you know, with the iPod and some of the other innovative things that he's done, that no customer said that they wanted that particular design. He, however, had a vision for that and was in a way able to anticipate the needs and able to come up with a good solution to a problem that no one prior to him could verbalize that. So it's not like people went up to him and said, build this with that. Not that Steve Jobs did it himself, but his organization under his control. The point is that you do need to listen to your customer. You do need to understand that they bring the subject matter expertise to the equation. They understand the business and they understand how it works. However, you can, through asking probing questions, by looking at things that don't quite make sense to you, you can dig a little bit deeper and, you know, kind of like I said there, that just didn't sit right with me, that there was those two things that were independent of each other, yet they seem to be related. And through that method, I came up with the extra entity. Questions about any of this? Yes?
Could you make the title an attribute and then the entity and then the books an attribute of that title? You know, number of books?
Well, that's a good question. The question is could we do something like this? Could we have an entity for titles? And it would have a primary key, title ID, maybe the ISBN number, the author, well, authors, description, title, and so on. And you're saying, could you have attributes there for the number of books? Well, let's think of what that would look like then. We could have a number of books here, but that wouldn't give us any information about whether they were used, new, or ebooks. One of the things that they do when they buy used books is they look to see how many used books they already have. Right? They already have, 1,000 used books. They're probably not going to buy back a particular book, or they're not going to give you as much money for it. All right? So, For the purposes of inventory, having a single number of books probably isn't sufficient. All right, so we can't do that. If we knew that we only ever would have one type of book, then maybe we could get by with that. So, one possible solution would be to say, all right, let's have number of new, number of used, number of ebook licenses. And for this, I'm thinking of something like My IT Lab, for those of you that had CISS243, where you actually get a license code to go in and access the materials that are on that site. All right, in which they actually do have physically something they sell you, which isn't a book, but it's a license, effectively. It's a passcode to get into there. Now, what's wrong with that picture? How is that restricted or limited? Well, it's limited to those three types of books, right? So when someone comes up with the super electronic hologrammatic virtual reality version of the textbook, you have a problem because you can't put it in any of those, and you'll have to make a structural change to the database to incorporate that. So, what do? Well, you might say to yourself, you know, I don't need to necessarily know detailed information about every single copy. I just need to know that in aggregate. So I might not need literally a book table that says, hey, you know, that has, if I have 50 copies of a book, I have 50 rows in that table. I don't necessarily need that. You know, if you think of inventory, you know, a candy store, are they going to have a row in their item table for every single pack of bubble gum they have? Probably not. That's ridiculous. So you could do something like this, though. I have my title table. All right. Key would be title ID, and that'd be the title of the book and the author and so on. Thanks. Nope. Nope. Title table. I could have my type table that would have a type ID and a description. So I'd have a row in there for new, a row in there for used, a row in there for ebook, and so on. All right. And then I could have a title type table whose primary key could be the title ID and the type ID, and whose attribute would be the number of copies. So I could do that if I wasn't really interested in having detailed information about every single book. All right, which, you know, thinking about it, you know, the CISS243 class, you know, there's hundreds of people that take that course every semester. Probably don't want a row in there for every book. I just want to know in aggregate how many new books, how many used books, how many ebooks I have. So then that would be sort of the alternative to doing it that way. So that's probably the best way to solve the way that you described and have the number as an attribute. You couldn't have it as a title because we truly want the number for several different types. All right. There's two more concepts that I want to talk about before we get into SQL, and then either end of class today or definitely next week get into actually accessing and pulling up information from a database on our web page. Those two items, concepts that I want to talk about, are normalization and what makes for a good primary key. All right. Now we talked about our general concepts last time, primary keys and foreign keys. We only hook tables together via primary key. We know that. We never put any other attribute from another table in a different table. So in the case of where we had a relationship between section and class, we would only put the ID of the class table in the section table. We wouldn't put the number of credit hours, for example, in the section table. We would not put the name of the class in there. We'd only put the class ID. All right. That gets into normalization. And I'm assuming you all, based on a show of hands last time, at least of the people that were here last time, you've all had CISS243 and you've all had the basics of normalization. So what I want to do is I just want to sort of hit the high points, and I just want this to be review. In essence, normalization says this, that any attribute only depends on the primary key and depends on the entire primary key. All right. Let's look at some tables in the example we just did and point to some potential normalization problems and point to how we would fix them. The first normalization rule, by the way, says no repeating fields. In other words, have the same data item several times. And that, in essence, was what was wrong with this solution. I have 3 quantity fields in there. Who's to say there's not going to be a 4th type, a 5th type, and so on? So by hard coding and having a repeating field like that, you really limit the flexibility of it. All right? Because there certainly is no reason to think that there won't be another method of delivering books. I mean, there already are that I didn't even think of, like audio books. You can buy a book on CD or whatever. All right, at any rate, let's cover a couple normalization problems. And I will pose the problem, and then we'll spend a minute talking about it. And I'll ask you to spot the problem. You know, what is wrong with this picture? All right. We already covered the first normalization rule, which is no repeating fields. Let's talk about the second normalization rule. We have this professor class table that contains a list of professors that are authorized to teach a certain class. So professor ID and class ID is the primary key. That establishes the connection of who's allowed to teach what class. If I had the professor's email address in here, what would be the problem with that picture? What's wrong with this picture?
Duplicate it for every class he taught.
Exactly. We would have, for every class that professor taught, we would record their email address. What's the problem with that? Well, it's a waste. I don't have a different email address for my 216 class than I do for my 243 class. All right? And so it would be a waste of space, waste of effort. If I change my email address, then there'd be several places it would have to be changed. And there's always a risk of inconsistencies then, because that one piece of information is stored in multiple places. This is yet another flavor of the programmer's mantra, DRY, do not repeat yourself. This is repeating information redundantly. All right? So what is the solution to this one? How would we fix that? Where would we put the professor's email address? Well, we'll put it in a professor table, right? Now, in formal normalization terms, the professor's email address only depends on the professor's ID. In other words, if I know the professor's ID, I know their email address. I can look up their email address. I don't have to know what class I'm talking about to do that, because a professor only has one email address. Therefore, again, the solution of this would be to put that as an attribute in the professor table. All right, let's come up with another normalization issue. And that, by the way, is an example of the second normalization rule, where something depends on only part of the key. All right, how about this? We have our book table. We're doing the model now. We're doing the model or the version now where we have a row for every individual book. All right. So we have a book ID as a primary key. There's essentially like a serial number assigned to it. One of the other attributes of this, a foreign key, would be the title ID that would point to the title table. And what would be the issue here of having the book title in that table? Same thing, redundancy. That every copy of the book, of course, is going to have the same title. As long as we relate this book back to the book title that it belongs to, there's no need for us to store the actual title. Therefore, this needs to be out of there and put in the title table. Again, all of these things point to how I like to summarize the normalization rules. And that is that every attribute needs to depend on the complete primary key of the table that it finds itself. If it doesn't appear, or I'm sorry, if it doesn't depend on the entire primary key, then it's in the wrong entity. Another way to look at the normalization rules are you're making sure that you have the right number of entities and you're associating the attributes with the correct entity. So, another example. If we were to put credit hours in the section table. Now we could talk about the normalization rules and that doesn't depend on the key to this table and so on and so forth. But from a common sense perspective, the real issue here is that it doesn't matter what section you're taking. Credit hours is an attribute of the class, not of the section. Two people taking different sections of the same class don't get a different number of credit hours. It's not like one person taking the web class gets 4 credit hours, and if you take the campus class, you get 3 credit hours. All right? So, if I put the credit hours in this table, really what I would be doing is I would be not associating the attribute with the proper entity. The credit hours really is an attribute of the class. Sometimes it's good to have and put a real-world focus on this, to forget about databases and just think logically, all right, about where does that seem like it belongs? Where does it make most sense for it to be? And a lot of times that points you in the right direction. All right? Okay. Proper keys. We talked about primary keys last time, what they are. Here's some guidelines for primary keys. And after we go through these guidelines, we'll come to a conclusion, all right, as far as primary keys. First guideline has to be something that every row has. That's by definition, right? That isn't even a guideline. That's a rule, all right? Every member of the entity has to have a primary key, or has to have a value for its primary key, rather, is probably more precise. And it has to be unique. So you can't have two people with the same student ID, let's say, if we're talking about a student table. A primary key can be multiple fields, and if they are multiple fields, then both fields have to have a value for every member of the entity, and the combination of those values, not any of those values individually, but the combination of those values would have to be unique. For example, I could make a table, an automobile table, that was keyed off of an automobile's license plate number. All right? But I'd have to include the state as well, right? Because there could be ABC123 in Ohio and ABC123 in Michigan. And if I was making that table, then if I just used the license plate number, that wouldn't work. But if I included the state, then I know the combination is going to be unique, because I can't have two plates in Ohio for ABC123. All right? That being said, in web applications, typically single part keys are preferable. And I'll tell you why that is. All right? One of the things that we do in web development is we create drop-downs based on data that's in a particular table. So, let's say, for example, I have an entry screen in the bookstore for a worker to enter in when they get a new book in inventory. In other words, I go and sell my used copy of the book. They're going to go and they're going to enter it in the inventory to say, "Hey, I got a new used copy of the book. I got an additional used copy of the book." So, screen might look something like this. I have a drop down for title. I'll have a drop down for the type of book it is, so that I can select used. Right? Maybe I'll have a field for comments about the book or whatever. But I'll probably have at least these two drop downs on the page, so that if someone's selling a used book back, so I can identify as a used book, not, say, a new book that they're simply returning. All right? And so I can select a title from the list of titles. Now, let's think about what these drop downs are going to look like. All right? Let's look at the title drop down. But the same thing applies to the type. What does a title table contain? The title table contains a title ID as a primary key, and I'll say title name for the name of the book. All right? Now, the book table is going to contain a book ID, and it's going to contain, among other information, it's going to contain a title ID that's going to be a foreign key over that's going to point to this value. So, if I'm selling Head Start Java or Head First Java, that has some title ID. Let's say the title ID is 123. That's for Head First Java. So, when I purchase this book from the student and I want to put it into our inventory saying we got another used copy of that, I'm going to want to put that title ID in the title ID foreign key in the book table. Likewise, the same thing for the type ID. I'm going to want to put the ID of the type. Maybe type 1 is a used book. All right? Now, let's think of how this drop-down is going to act then. Am I going to want to show the title IDs to the person purchasing that book? No. They're not going to remember that Head First Java is... What's the ID for Head First Java? See, you don't remember, and it was just up a second ago. I don't think I remember either. What did I say? Oh, I said it was 1, 2, 3. All right. If I can't remember it from the time then to the time where I looked at that again, how is someone at the bookstore going to remember the book ID for hundreds of books across campus? Oh, this is the art history book? Yeah, that's book number 47923. They're not going to remember that. But they will be able to recognize the title, right? Because they have the book right in front of them. And they look and they say, oh, okay, this is Head First Java. Therefore, this drop-down should display the name of the book. Something that a human can recognize and can understand. However, remember, we don't need to stuff the name of the book in that title field, foreign key. We need to stick the ID in there. So guess what? The value of this drop-down is going to be the ID. So, if I could create the HTML for what this drop-down would look like, it's going to have a series of option tags, whereas the value is going to be the value for the primary key for that table. So for Head First Java, the value is going to be 1, 2, 3. I will then have the title as being the text of the option tag. So in other words, remember that associated with the dropdown, there's always the text that the user sees that's understandable for the user. All right. And there is always the value that is sort of what is seen behind the scenes. Well, in the case of a dropdown, if that dropdown is coming from a database table, we want the text to be whatever is going to be understandable to the user. We want the value to be the primary key to that table. Well, what happens if something has a multiple part primary key? Ooh, we're kind of in a sticky wicket, as they say. We don't really know. I don't have a good answer for what you would do in that case. All right? So because of that, while it's true in general that single part primary keys are typically preferable, it's doubly true in the case of web applications that single part primary keys, at the very least for the tables that you're going to use in a drop-down, in a table that you're going to use to select the value that way, ought to be single part keys. Yes?
That be where you use I think it's a surrogate key.
Yeah.
Where you use an auto
Exactly. Exactly. This is going to be the conclusion, the spoiler alert. If you're watching this video and you don't want the spoiler, turn it off for 30 seconds. Every characteristic of a primary key that we say is a good characteristic for a web application is going to turn out to be a auto number key, what's called an auto number key in Access or a surrogate key in other databases, where it's simply automatically numbered. The first row gets an ID of 1, the second row gets an ID of 2, and so on down the line. So that's sort of the punchline from all this, that, hey, that's pretty safe to do it that way for all the reasons we're cited. Typically, again, some of the other guidelines, numeric is better than alphanumeric, because you might say, gee, why not just make the title name the primary key? Well, if you did that, then how, book titles, especially textbook titles, can be a bunch of characters, and that would take up tons of space as part of the primary key and as part of any foreign keys that was involved in. A number can be stored in a very compressed manner, so it's better. So, single part better than double part, number better than alphanumeric. As smaller is better than bigger. All these things point to using a surrogate key. again, or using, in the case of access, a auto number key. Now, some of these things we'll talk about later on, like what happens if you have an intersecting entity. How do you make a single part key for that? You can. You do have to go and apply an index then if you want to constrain that combination of keys to be unique. Like I could make, for example, this one. This table here that has professor ID and class ID as a primary key, I could actually make a surrogate key, a professor class ID, but then I'd have to have a unique index on this to make sure that a given combination of professor and class only was in there once. Because it's enough to say that I'm authorized to teach this class. It would just lead to difficulty if you could put 2 rows in there indicating that I could teach this class. All right. Any questions at this point? I do have to, how do I want to put this? I do have to, if I seem a little scatterbrained today, I am not feeling very well. I have a little sort of an upset stomach, so I think my head might be in another place. All right? So I do apologize if there's a little bit of scatteredness in the tone of the lecture. What I'd like to do now with the remaining time, or at least part of the remaining time, is run into and do a quick example of pulling data from a database and showing it on a web form. Here's a database, typical Northwood database, which is a sample database that comes with Access. I'm going to go and I'm going to make a web form that's going to contain a listing of rows from a certain table. Now that we've gone over the basic concepts, as we cover SQL, we'll sort of do it in tandem. In other words, I'll spend a little bit of time talking about SQL statements, and then we'll go and implement them in Access. So let's look at this database, and let's look at one of the tables, and let's talk a little bit about the SQL involved. I'm not going to talk about everything in a SQL select, but I will talk about some of the highlights. All right. This is a table that has, a faculty table and so on. And that will be the table that we'll use in our first example. All right. There is a faculty ID, which is FID, an FL name, an FF name, and so on down the line. All right. This has a couple of foreign keys, one for location, which is like their office, and one for their faculty rank. All right. That isn't frank. Like if, they have franking privileges where they can send mail without paying for it. Or they like Frank Sinatra or anything like that. All right, that should be the faculty rank. All right. It does bother me when people overly abbreviate stuff, right? Because that can be confusing, Take the time and spell it out, or at least do that. Actually, one job I was on, they had a list of authorized abbreviations. Now, you might think this is crazy, but this is a multinational, big machine manufacturing, equipment manufacturing organization with things around the world and dozens of different applications. So if you wanted to say, if you had a field, let's say, that you wanted to call machine description, you'd look up in their list of abbreviations and see what the authorized abbreviation for machine is. And it might be MACH or MCH or something like that. And description might be DESC. Now, what do you gain from that? You gain from that that anyone in the world looks and sees a field called MACHDESC, they can go to their book and say, that relates to the machine description. All right? And there's no ambiguity or anything like that. There's a very consistent way. That again, these sort of consistency and standards become a much bigger issue when you're working in a giant organization, all right, where you have to coordinate the efforts of a lot of different people. It is good, whether you publish a list of authorized abbreviations or not, to apply some sort of internal standards. And whatever you call something in one table, call it by the same thing in another table. All right. One application I worked on, it was another case of really having to apply your intelligence and asking the user, because they called food manufacturers, depending on the context, they would call food manufacturers either manufacturers or principals, depending on the particular context they were saying that in. So if you uncritically listen to them, you might think that you need two tables, a manufacturer table and a principal table, when really it's just the same entity looked at from two different perspectives. Same thing with customers and distributors. All right? Customers and distributors really were the same thing, but there were different people talking about a different aspect of the job. All right? At any rate, a select statement for this table might look something like this. And I'm going to start with the absolute simplest select statement that we can have, and then in subsequent classes we'll build on that. All right? Because again, we're going to sort of build the SQL skills alongside of our ASP.NET skills. So the simplest form of the select is something like this. Select star from faculty. All right? The star represents every column in that table. All queries start out with the word select. You then list the columns that you want to see. As a wildcard, you can put an asterisk in to say all columns. You have the word from, and then you have the table that you want to select from. Now, these get more complicated than that, but this is the simplest form of it, and this is the one that we're going to start out with. This doesn't filter out and only show me certain faculty. This will show me all the faculty members. All right? So, let's go see how we could get a listing that looks similar to this on a web page. All right? So I'm going to go in and I'm going to create a new application in Visual Studio. I will say it does make for an interesting experience when you're not feeling well and your lecture is being recorded, because, I have thoughts in my head of going viral with the, professor throwing up in front of his ASP.NET class. I don't want to achieve that level of notoriety, all right? So if you see me flying out of the room, even that probably would be pretty funny and would probably make the rounds. At the very least, of course, I guess someone could edit it. I would say at the very least, if I do it now, you'd have to sit through an hour of the lecture to get to that point. So, all right. I'm going to go and I'm going to create my application. File, new website. And I'll call it Northwood's Example. And I'm going to create a website versus a empty website. All right, and we'll talk a little bit about why, just for variety's sake and because I want to show you some of the folders that get created, one of them specifically. And I'll go and I'll call this Northwood's website. Yep. All right, so it goes and does its thing. And it's going to create that folder, and it's going to put more stuff in that folder. There's one particular thing in that folder that I'm interested in. And that is this folder here, the app data folder. That's a special folder. That's a folder that's going to contain our database. Let me rephrase that. That's a folder that can contain our database. There's a lot of ways that you can configure your web application to work with a database. But in our case, it's going to be where we're going to put our database. Why put it there? Why not just put it in the application folder with the rest of the files? Because we want some special security applied to that folder. We don't want people to be able to try to access the data that's in that folder. And there's special security applied to this app data folder. If you look, notice that that folder looks a little bit different visually in my Solution Explorer. All right. So I'm going to go and I'm going to copy that file, my database file, into the app data folder. Actually, I'll just move it there. Then I'm going to go here and hit refresh. So now I can see that it's there. All right. All righty. I'm going to go then and I'm going to create a new page, new file, and I'm going to call it faculty list. And I want to select the master page. All right, this will be good practice in doing that. I know you have a lab due with that pretty soon. And I'm going to click Add. And then it asks me which master page we want, and I'll pick the master page that it gave me, Site Master. All right. Notice that in my faculty list page, I can only put stuff in that Content 2 area. Right? I can't put anything out of there. Remember, the content tags are sort of the blanks that you're going to fill in on each page that inherits from your master page. So I'm going to go to Design View for this, and I'm going to put under Data, I'm going to put a grid view. Now, a grid view should be pretty obvious from looking at it. This is going to get translated to an HTML table. All right? It looks like a table. We can go and we can use auto format and use any of these lovely formats that we want. Let's use this one. And just like when we did the sitemap path or we did the menu, notice we have an option to choose the data source. All right. What we're going to do is we're going to create a data source and sort of bind those two things together. Bind the data source to that visual control. Just like we bound our sitemap file to the menu control or the sitemap path. All right. So I'm going to go here and I'm going to say I want a new data source because I don't have any data sources. It's going to walk me through a process. What kind of database is it? All right. It's actually, even though it's an Access database, we can select a SQL database control. Access database is more for the earlier versions of Access. We can give an ID for that data source. All right. And we can call it SQL Data Source 1, or how about SQL Data Source Faculty, because that's what we're going to do with this data source. We're going to retrieve faculty information. Click OK. It will now ask me for what database connection I want. All right. What database do I want to connect to? All right. That data source object that I created a second ago is going to contain my data from the database. But before we can get that data from the database, we have to say what database we want to connect to. So, I don't have any connection strings here. All right. So I'm going to click New Connection. Access Database. And it will ask me, where is that database? And I'll go and I'll point to my desktop. Access database in the app data folder. I can click Test Connection, and it can connect to it. It will ask me if I want to save this connection string, and I probably do want to. In fact, yes, I will virtually always say I want to. Why is that? Because we're going to use this connection string over and over and over again. The reason that we had to define this is because this is the first thing we're doing in this application. This is the first database connectivity we're doing in this application. So we have to tell it what database we want to use for that. Chances are, each subsequent database interaction that we're going to do, we're going to hit the same database. So we can use the same connection. Now there may be rare cases where you have one application hitting two databases, but those will be the exception. So I'm going to save it, and I'm going to save it as Northwood connection string, or Northwood's connection string. That will actually put it in my web config file. Now, I can go in and I can specify the SQL statement I want, or I can use this sort of visual GUI thing to do it. I'm going to go in and specify the SQL statement I want because I want to practice the SQL statements. So I'll click Next, and I'll say select star from faculty. All right. Click Next. I can test my query. All right. I know I did it right because it showed me results. Notice how I'm teaching or testing each component as I create it. When I created the connection, I tested the connection. Right? If for whatever reason you have a more complicated setup and you can't connect to that database, no sense spinning your wheels trying to debug your SQL statement when it blows up on you. Right? Figure that connection issue out first and then go on to the next step. And then I can click Finish. Now you'll notice, again, I have two objects on the page. The data, which is my SQL data source, and my grid view, which is the way that the data is being presented. All right? If I look in my web config file, the the way I created it created this goofy. So let me go and correct that. We'll talk more about that next time because I do want to get through this complete example. All right. But do notice that connection string is in the web config file, which means I can use it elsewhere in my application. So now I go and run this. It'll probably bring up the default page because I didn't have the faculty list page selected, but we can navigate to the faculty list page. All right. I can just type in my URL, faculty. Shoot. There we go. And there we have our list from our database appearing on that page. Now, if you didn't catch what I did, that's fine, especially about setting the connection string. We'll talk a little bit more about that next time. But that, in essence, is what we have. We have our database. The three players, sort of, in this are going to be the connection string, which you define once per database. That gets stored in the web config file. You then are going to have a data source that will be where you're going to store each little packet of data that you need on your page. So in this case, I needed a faculty list, so my faculty information gets put in that one data source. And lastly, I have my visual display for it, which in this case is a grid view. And that's probably the simplest visual display that we can have. We'll talk about others throughout the semester. Any questions on this? All right. I will save this, and we will then go to lab. All right.